Okay, so the second important concept of approximation is the concept of significant figures. Now, this is pretty interesting and very intuitive concept to learn. So I will actually give an example for this so that you understand it better. So the first thing that you need to see here is that in O levels, if you're a physics student, which I assume you would be, since you're learning mathematics, so it would be, safe to assume that you would be learning physics. You would come across the value of g, the gravitational constant, and you would be using it as 10 meters per second squares, right, the gravitational acceleration, right? And you would actually be using it in formulas to calculate, for example, the weight of yours, which is the product of mass into the gravitational constant g, right? So if you want to calculate your weight, you just need to multiply your mass with this value of g, which is 10. But the exact value of g is not 10 meter per second squared. It is the exact value of g that is there is 9.80665. 9.80665 meters per second square. So how did this value become this value? Why are you not using this value and using 10 instead of this pretty large looking value? So the answer to that is the concept of significant figures. Because the scientists who are working in SpaceX or NASA are using this value, and you in O levels are using just this small value of 10, not the exact value. Because the engineers and the scientists who are programming their spaceships and rockets are feeding this exact value into their systems so that their systems can work precisely. So if they want to, for example, calculate the weight of some component of their rocket or spacecraft, then they would be using this value of g so that they can multiply it with the mass of that and they get exact weight. Because a small deviation in the calculation of weight, because for example you can use the value of 10 instead of 9.80665, and you will get a different result. You would actually get a greater result if you use the value of 10 instead of 9.8665. And the reason to that is because 10 is greater than this value, right? So you can afford to do that because you're not interested in your exact weight. You just want your approximated weight. For example, your mass is, for example, 60 kgs, and you just multiply it with 10 and you get a 600 newton. So you say, yeah, my weight is around 600 newton, because you're not interested in your exact weight. However, the weight of the astronaut who lives in the space station, perhaps he would want to know his exact weight so that he could, perhaps he would want that data for any reason. So he would instead be using this exact value because he don't want to be imprecise at all. So he would be using this. So he would actually be giving some care to these numbers that come after this decimal point. So he is considering all these numbers to be significant. What you did in your, or what you are doing in your O levels, is just you're just putting a 10, and then no matter how many zeros you put, you're considering all those zeros to be insignificant, right? So you're just reducing the significance of some of the digits of this value so that you can actually use it for your convenience, so that you can, I just calculated my weight to be 600 newton without even using a calculator. But if I, for example, use the value 9.86 as 80665, I would have definitely needed a calculator or some mathematical working, and it could have wasted my time. So I'm not interested in my exact weight. I'm just interested in the concept, how this works. That is why I'm using this value. In A levels, you would be using 9.81, perhaps, right? So this is a three significant figure value. So you're just being, customized to use this value as well, so that you can always be familiar with using this value in calculator. But in, for example, spacecrafts and agencies like NASA and SpaceX, you would be required to use this value. So the concept of significant figure, the importance that this video is talking about, is that so that you understand why are we using the concept of significant figures. I have trouble saying this. By the way, this how we can how can we actually calculate the number of significant figures in a value, and how we can reduce a value to certain significant figures, is something that we'll be learning in the next video.